Consider this quarter circle. Say we inscribe a semicircle as shown, such that the semicircle is tangent at 2 points on the sides of the quarter circle. What fraction is the area of the semicircle? Let's begin. First, locate the center of the semicircle. Assume that the radius of the semicircle is r. From the center of the semicircle, draw a horizontal segment to the tangent point. Also, draw a vertical segment from the center to the other tangent point. We know that the central angle of a quarter circle is 90 degrees. And since we have 3 right angles, this fourth angle must also be a right angle. The radius of the semicircle is r, therefore this is r, and this is also r. Now we have formed a square with side lengths r. As we know, the diagonal of a square creates a 45-45-90 special right triangle, which means the diagonal's length is r square root of 2. Next, we can observe that the diagonal of the square is also the perpendicular bisector of this chord, since it divides the chord into 2 equal segments. So this gotta be a right angle. If we let n be the radius of the quarter circle, therefore this distance is also n. Let's apply the Pythagorean theorem on the highlighted right triangle. R square root of 2 all squared plus r squared is equal to n squared. This becomes r squared times 2 plus r squared equals n squared. Combine like terms, we should get 3r squared equals n squared. Now the fraction of the area that is shaded is equal to the area of the semicircle divided by the area of the quarter circle. The area of the semicircle is 1/2 times pi time radius squared. The area of the quarter circle is 1/4 times pi times radius squared. Substitute n squared equals 3r squared into the equation. All right, let's substitute. We can cancel out pi and also r squared. Multiply these to get 3/4. And finally, 1/2 divided by 3/4 is 2/3. The semicircle is 2/3 of the area of the quarter circle. Thanks for watching. Please subscribe to my channel for more engaging math puzzles.